In order to be fully recycled, the batteries in our phones, laptops and electric cars have to be transported across the world. A project called LiCoRICE, based in UCD and part of Science Foundation Ireland's Zero Emissions Challenge, have come up with a new and environmentally friendly way to recycle rechargeable batteries.
So what we're looking to do is to recycle all of the lithium-ion batteries that are used and discarded in Ireland. So it's a big problem at the moment. We, Ireland, collected 48 tonnes of lithium-ion battery waste last year. And while they're technically recyclable, it's a really high energy process, it's pretty dirty, the metals, powders and wastes and everything. And it involves a lot of transport to and fro across the world. So we're looking to have a process where we're able to take the material out of the batteries and do all the processing on site here. That in itself gives out zero emissions and also increases the amount of cobalt available for electric vehicle batteries.
Is this a breakthrough discovery, would you say? Is anybody else doing anything like it?
What we're doing is completely new in that we have a sort of a compound that we're closely guarding as a secret, but it's sort of a bit of an intermediate, which we then can turn into battery material. What we're making is the equivalent of, say, if you get some wood and then you cook it and it forms charcoal. It's more useful in that state. And it's that bit in the middle that's brand new. It's a brand new compound, it's not been seen before.
Okay.
And it's got all the properties we need to make this a low energy, clean process.
This low energy way of recycling the cobalt and lithium from old rechargeable batteries happened by a chance discovery in the lab.
I think pretty much everyone understands you've got to experiment. I mean, that's the point of science, experimentation. You don't always know what you're going to make. So we made something by accident. It wasn't what we thought it was going to be, but it looked really interesting. The way that we do these things, we do the reactions in sealed containers. You can't see what's going on. And you open the container and there at the bottom of the liquid, there's either crystals or there's rubbish, and sometimes a bit of both. And in this case, we could see something glinting at the bottom. So we fished it out, we had a look. But it was when we did some analysis on it, and one of the types of analysis we do is we burn the compound and we see what's left in the ash. That's when it got us. Suddenly it was like, hang on a minute, we're making the stuff from batteries here. So all of a sudden we thought, well, this could actually be useful.
Tony and his team have come up with a method of recycling lithium cobalt batteries in a very sustainable way. It's then up to chemical engineer Stephen and his team to take it from benchtop process to prototype.
So my role in the project is to figure out how to take Tony's novel process and to make it operate on very large scales. So what we're going to do is take this small scale idea and new material and build a factory out of it that will be able to produce and recycle lithium-ion batteries from Irish sources and ideally global sources. So we want to make it very scalable. So I was really excited when Tony told me about the process. Like, this is quite a big deal. So to be able to manufacture this in such a low energy way is not something you would think would be theoretically possible from looking at the scientific literature or industry processes. So whenever you have something that can make a contribution to such a huge problem that affects society and the world in general, like climate change or recycling of materials, that's just an exciting thing to be able to work towards.
At the moment, we burn fuel and that's gone forever. With electric vehicles, obviously we can recharge, but that charge degrades over time. Are you saying that the LiCoRICE process would mean we could reuse the same batteries indefinitely? Yeah,
in the LiCoRICE process, we take in degraded battery material. So the lithium-ion batteries gradually lose their ability to hold as much charge. We know this from our mobile phones over time. But that material isn't lost in the way it is in combustion engines where the fuel is lost to the atmosphere. So yeah, we can take those in, degraded batteries, retreat them, and then reformulate them, and they go back out as new batteries with ideally even more efficient formulations. With little or no material lost is our goal. And this is part of the circular economy which we're trying to move batteries into, whereby any material we put into a battery will be in batteries in perpetuity, assuming the materials we make them out of don't change completely.
Countries are aiming for 2030 phasing out petrol and diesel vehicles. We need those batteries because at the moment electric vehicles make up a few % of the market. By 2030 you can only buy electric vehicles. So the number of batteries to deal with will be immense, and the current recycling and reprocessing schemes just can't cope with that. So if we can actually get our process up and running and spread around the world, then we can cope with all of this, and we can not just solve our waste problem, we can also reduce the CO2 emissions both through what we're doing and in transport, but we can also make electric vehicles more accessible to everyone.